Sebelum kita mulakan majlis, kita baca ummul kitab. Mudah-mudahan majlis kita akan lebih diberkati. Al-Fatihah. Alhamdulillah, bersyukur kita kepada Allah pada petang ini kita dapat menjalankan sesi kolokium bulan September. Atas saranan KPP, kolokium kali ini kita salurkan juga melalui channel YouTube dan boleh dicapai di seluruh negara. Kita juga menjemput UiTM Cawangan untuk bersama-sama kita pada petang ini. Jadi pada petang ini terdapat seorang pembentang iaitu Dr. Syazana binti Anuar. Jadi serba sedikit latar belakang pendidikan pembentang. Ijazah pertama Bachelor of Science, Honours Major dalam Matematik daripada Universiti Putra Malaysia, Master of Science Matematik daripada Universiti Kebangsaan Malaysia, dan Doctor of Philosophy kepakaran dalam Fluid Dynamic juga daripada Universiti Putra Malaysia. Tajuk pembentangan beliau pada petang ini ialah MHD Flow Past a Nonlinear Shrinking Sheet in Carbon Nanotubes Stability Analysis. Tanpa membuang masa, majlis mempersilakan Dr. Syazana untuk berucap. Dipersilakan.
Okay, terima kasih Dr. Agus. Okay, Assalamualaikum warahmatullahi wabarakatuh and a very good evening. My name is Syazana binti Anuar. Today I'm going to present one of my PhD studies entitled MHD Flow Past a Nonlinear Shrinking Sheet in Carbon Nanotube Stability Analysis. There is one of my PhD work and it have been published in Chinese Journal of Physics in 2020. This paper is work done with my supervisor, Associate Professor Dr. Nofifa Bacho, and co-supervisor Professor Norehan Ma'arifin and Dr. Haliza Rosali from Universiti Putra Malaysia. Today's presentations consist of some introduction, problem statement, research methodology, results and discussion, conclusion, and the last one is future research. So I will tell you some about keywords in this problem, in this research. Boundary layer is the layer of fluid closest to the surface of an object where the fluid flow through it. And it was first introduced by Luis Prantl in 1904. Boundary layer is a layer, basically it is a layer between a fluid and the surface. For the stagnation point flow, it is a point in a flow field where the local velocity of the fluid is zero. As you can see from this figure, there is known as stagnation point, and we will also have a stagnation point flow around it. The stagnation region encounter the highest pressure, heat transfer, and also the highest rates of mass deposition. From the title itself, it have a stretching and shrinking sheet. Everyone know what is meant by stretching and shrinking. So stretching is when something, when velocity at the boundary is moved away from a fixed point. An application of stretching can be seen in paper production and glass blowing, while shrinking occurs when velocity at the boundary moving towards a fixed point. An application can be seen in shrink wrapping. From the title, we have MHD. MHD is a magnetohydrodynamics. It is a branch of continuum mechanics that deals with the motion of an electrically conducting fluid in the presence of magnetic field. So the word magnetohydrodynamic is derived from magneto, which means the magnetic field, Hydro is water. Dynamics is the movement. We also use a nanofluid. Nanofluid is the combinations of base fluid and nanoparticles with the diameter 1 to 100 nanometer. As you can see in this figure, there is an example. We have a nanoparticle here and the nano layer and also base fluid. Nanoparticles have many. For example, we have metal, oxides, and carbon nanotube. In this research, we are focusing on using carbon nanotube as a nanoparticle. So carbon nanotube consists of two types, which are single-wall carbon nanotube and multi-wall carbon nanotube. Single-wall carbon nanotube consists of single graphene cylinder with the diameter of 0.5 to 1.5 nanometer and have a thermal conductivity up to 6,600. While multi-wall carbon nanotube consists of several graphene cylinder with the diameter greater than 100 nanometer and have the thermal conductivity up to 3,000. For the stability analysis, the reason why we study stability analysis is because the existence of dual solution, as can be seen from this figure from Merkin in 1985, there exists two solutions for one parameter involved. So with this, we are doing an analysis to identify which of these solution is a stable solution. So the stability of the solution are determined by the smallest eigenvalue gamma. And gamma is the growth or decay rate of the disturbance. As you can see, if the obtained gamma positive, we say that there is an only initial decay that doesn't interrupt the flow, which we can conclude that the solution is stable. While if the obtained gamma is negative, we can say that there exists an initial growth of disturbance in the system, where we can conclude that the solution is unstable. So the motivations of this research is done because of an experimental investigation have been done by Singh et al. In 2012, where they found that carbon nanotube offer a higher thermal conductivity when compared to other nanoparticles. Other than that, we can see carbon nanotube have many applications in industrial, such as in electronics, nanotechnologies, biotechnology, materials, and energy. So the problem statement for this research is the idea of using carbon nanotube has increased over past few years. So this research will help us to understand the heat transfer process, hence can improve the quality of the products. So we have some research questions to answer for this problem. The first is we want to know what is the parameter involved that contribute to the existence of dual solution, and which parameter contributes to the widening or narrowing the range of solution. We also want to know how does the presence of carbon nanotube, which is the nanoparticle itself, give the impact on the flow and heat transfer. We also interest in the skin friction and local Nusselt number. What happened for the skin friction and local Nusselt number when there is a changes in physical parameters. And the last one is for the stability analysis. We would like to identify which of these solution is a stable solution. So that's all for the introduction and problem statement. Next, we will proceed to the research methodology. Our research consists of two parts. So the first part is to obtain the velocity profile, temperature profile, skin friction, and also local Nusselt number. So first, we will have the mathematical model in partial differential equations, PDE. And then we transform our PDEs into ordinary differential equation, ODE, using the similarity transformation. Afterwards, we apply the first order ordinary differential equations into MATLAB, and we implement the BVP4C built-in function. With this, we will obtain our numerical results in terms of figures and tables. While for the second part, it is basically for the stability part. So the first is we will have the mathematical model. It is same as the previous, but we consider it in unsteady case. We introduce the term time. Afterwards, we introduce the new similarity variables and we define the new time dimensionless variable, which is tau. We also introduce the linear eigenvalue equations and we will derive the partial differential equations into ordinary differential equations. For the numerical procedure, we use the same software, which is a MATLAB software, and using the built-in function BVP4C. And finally, we will obtain the eigenvalue gamma. Since we are using carbon nanotube, so the effective properties of nanofluid are taken from Ostov and Abu Nada. We are using the first model. So the difference here is the thermal conductivity from Ostov and Abu Nada are changed to ZU 2005 because it is more suitable for our nanoparticle, which are carbon nanotube. And the thermophysical properties of carbon nanotube and base fluid are taken from Han et al. 2014. So in this research, we are going to use single-wall carbon nanotube and multi-wall carbon nanotube as a nanoparticle, while the base fluid, we are going to look at water and kerosene. For the mathematical model, here we have the physical model for stretching sheet and physical model for the shrinking sheet. So from this model, the flow is generated by stretching or shrinking of the sheet. So the flow is, the velocity is identified by UW in a nonlinear, since we are considering a nonlinear stretching or shrinking sheet. We also have the free stream velocity, which denoted by U infinity. In addition, as I mentioned previous, we have MHD or magnetohydrodynamic. So an external magnetic field is applied normal to the sheet, which denoted by B here, also in a nonlinear. We also assume that the base fluid and nanoparticles are in thermal equilibrium and no slip occurs between them. Okay, so let's proceed for mathematical formulation for the first part. Okay, here we have, according to when refers to the previous assumptions, so we will have our partial differential equation, which consists of continuity equation here, momentum equation, and energy equation. Okay, the red one is a magnetic fields B here, together with the boundary condition. Here we have UW, which indicate the stretching shrinking flow. To implement the similarity variables here, we will obtain our ordinary differential equation here. So in this, we have N, which I identify as a nonlinear parameter. M is a magnetic field. And also we have boundary condition where we have epsilon is a stretching shrinking parameter. We also interest in the physical quantities, which are skin friction and local Nusselt number. So for the first part, first we need to validate our result. So we have validated our result with the Bacho et al. 2011. From this, the result shows a very good agreement. So we are assured that our programming is correct. So the parameter involved here that we will see is epsilon, which is stretching shrinking parameter, where when epsilon less than 0, it's indicate the shrinking sheet. If epsilon more than 0, it is a stretching sheet. N is a nonlinear parameter. M is a magnetic parameter, and P is a nanoparticle volume fraction. So for the result here, we have the velocity profile and temperature profile for the different nanoparticles and also for different nonlinear parameter. So what we can see from this profile, This profile do meet the boundary condition asymptotically according to their boundary condition. In addition, we can also see that there is a dashed line and solid line. The solid line represent the first solution. The dashed line represent the second solution. So it is obvious that there exists two solutions from this figure. So with that, we are aimed to identify which parameter that contribute to the existence of dual solution. In addition to that, we also notice that the first solution have a thinner boundary layer compared to the second solution. So in order to identify which parameter contribute to the existence of two solutions, so we plot the figure F'0, reduced skin friction and a reduced heat transfer. So from here, from this figure, we can see that it is a versus epsilon stretching shrinking parameter. When epsilon is -1, which means the shrinking case, but more than its critical value, epsilon C, there exists two solutions, which is here, the dashed line and also the solid line. So from here, we conclude that there exists dual solution when epsilon less than -1, but more than its critical value. When epsilon more than -1, which is the positive, it only shows a unique solution. It can be seen from other figures as well. So we conclude here that a unique solution, one solution exists for the case of stretching shade. However, there is no solution when epsilon less than its critical value. So with this, the boundary layer equations can no longer be used, so they have to solve the Navier-Stokes equations. To answer the second research questions, what parameter contributes to widening or narrowing the range of solutions? So from this, we can see that as we increase n nonlinear parameter and also magnetic parameter, we can see that it expands the range of dual solution to exist, which is it widening the range of solution. And it also delay the boundary layer separation to happen. For our physical quantities of interest, we have skin friction and local Nusselt number. So from this figure, we have skin friction and local Nusselt number for different M magnetic field. So what we can conclude here, as the magnetic parameter increase, the skin friction here increase as well as the local Nusselt number. So this figure also shows versus nanoparticle VAV. As the nanoparticle increase from 0 to 0.2, we can see that the skin friction also increases as well as the local Nusselt number as the nanoparticle increase from 0 to 0.2. And in terms of carbon nanotube, we have been compared with the single wall and multi-wall, where the single wall is represented by the square box here and multi-wall are represented by the circle here. So from here, we can see that single wall carbon nanotube offer a higher skin friction as well as a higher local Nusselt number when compared to multi-wall carbon nanotube. From this figure also, we would love to compare the water-based and kerosene-based carbon nanotube. So from this, when we compare, we found that kerosene, this figure and this figure, shows a very higher skin friction and local Nusselt number when compared to water-based carbon nanotube. So that's all for the first part. For the second part is for the stability analysis. As I mentioned previous, we have the same PDE, but we introduce it in unsteady. So we introduce it in terms of time here. But the boundary condition is also the same. Implement the similarity variable here. We introduce the new time dimensionless here. And we will get this PDE. Afterwards, we introduce the linear eigenvalue function here. and then we will obtain our ordinary differential equation. So in this ordinary differential equation, we have an additional term gamma. So the gamma here will identify either the solution is stable or unstable. So we have a table here. When plot in a coding BVP4C in MATLAB, we have the first solution shows a positive smallest eigenvalue gamma, while the second solution shows a negative value. So in addition to that, as the value of epsilon approaching to its critical value here, as you can see here, it approach its critical. The value of gamma also approaching or drawn closer to 0. So with this, we can conclude that the first solution is a stable solution, while the second solution is unstable solution. So now we are in a conclusion part. The existence of the solution can be seen only for the case of shrinking surface. Meanwhile, the range of symmetry solutions, we can see that the presence of nonlinear N and magnetic M can widen the range of solution. For the case of carbon nanotube, we can see that increasing of nanoparticle volume fraction causes the local skin friction and local Nusselt number to increase. Single wall carbon nanotube and kerosene-based carbon nanotube also offer a higher skin friction and local Nusselt number when compared to multi-wall carbon nanotube and water-based carbon nanotube. So the other parameter involved in this research is we have the magnetic parameter. Increasing the magnetic parameter causes the local skin friction and local Nusselt number to increase. And the last one is for the stability analysis. We found that the first solution is a stable solution, while the second solution is unstable solution. Okay, for the future research, I would love to extend my research to the case of hybrid nanofluid, since today most of the study are focusing on hybrid nanofluid because it can enhance the heat transfer rate compared to ordinary nanofluid. So hybrid nanofluid is the mixture of hybrid nanometer particles and base fluid. So we can use a single wall carbon nanotube and multi-wall carbon nanotube with the water as a base fluid, so it will have a hybrid nanofluid. Other than that, we can also consider the different geometry. Previously, I just doing a flat plate, stretching, shrinking sheet, moving. So we can study in a curved surfaces, maybe in a stretching, shrinking curve, cone, thin needles, and also in cylinder. So if there is any lecturers or researchers who would love to give a contributions, would love to give an idea and collaborate with me, can feel free to contact me so we can make a more novelty rather than just a simple research here. So that's all from me. Thank you. So any questions?
Okay, terima kasih Dr. Nur Syazana. Saya buka untuk para pensyarah bertanya soalan atau mohon sebarang pencerahan dan sebagainya, terutama dalam bidang fluid dynamics. Kepada peserta yang mengikuti kolokium ini melalui saluran YouTube, boleh bertanya soalan melalui chatting. PJK bertugas, Puan Salmah akan membantu untuk menyampaikan soalan tersebut. Dipersilakan, siapa yang ada soalan boleh bertanya.
Assalamualaikum warahmatullahi and good afternoon to everyone. Okay, salam perkenalan Dr. Syazana. Tak pernah jumpa kan?
Saya baru je daftar, baru lapor diri bulan 7.
Subhanallah. Patut comel je ni. Okay. Okay, I'm Huzaimah, yeah. Okay. On the last slide, you mentioned about the stable and unstable solutions. Yeah, since you got dual solutions. May I know what does it mean by stable and unstable solution? What do you mean by stable?
A stable solution means that
Thank you very much.
Stable solution means that we can use the solutions, we can use the physical interpretations of that solution. We were from the previous, we conclude that second solution is unstable, so we cannot use the physical interpretations of that second solution. Menjawab tak, Doktor?
And what is the application of CNT, carbon nanotube, in engineering or maybe in industry?
I just selalu usually orang use biasalah aluminium and copper, right, for their nanoparticles, but they can change it into a carbon nanotube. Dia akan sama je application as a previous nanofluid. Ada juga application dalam medicals, tapi saya tak tulis lah dalam slide. Tapi ada. Saya ada research paper dalam yang menggunakan carbon nanotube dalam medicals and other application.
If I'm mistaken, one of the application yang I have heard is about as a coolant. Dalam tu nak menunjukkan air kereta kita tu kan, the coolant, the nanoparticle is actually it is mixed with the CNT tu. Yang saya ada dengar lah, yang saya ada baca.
Dia tukar
many applications.
Nanoparticles ni betul. Kita boleh ubah. Biasa kita akan guna copper and aluminium and many more, so we can use single wall or multi wall carbon nanotube as a nanoparticle juga. Sebab kita daripada previous experimental juga, dorang shows that carbon nanotube have a higher thermal conductivity compared to aluminium and copper. Okay. And the methods you use is in doing your research, what kind of method you apply? Yang lain doktor sabar kejap. Numerical method ke? Yes. Saya guna built-in function BVP4C in MATLAB. Okay. Okay, thank you. I am familiar with that. Okay, thank you very much, Dr. Syazana. Okay.
Okay, Dr. Agus, ada soalan daripada peserta di YouTube.
Okay. Boleh Puan-Puan membagikan terus soalan tu?
Daripada Fatihah Hero. Soalannya berbunyi begini. Just now you mentioned that you introduced the new similarity variable that is tau for stability analysis. May you share on how you obtain it for this problem? And then dia mention, I'm sure different problem will involve different tau, right? So itu soalan yang pertama lah. So far itu soalan.
Okay, for how I obtain the tau, okay, the working progress is long, but you can identify the tau when you derive the equation, when you derive the PDEs into ODE, and the terms that you cross is basically the tau. You can try it. If you want me to show, I don't have, but I can share it if you give me an email, so I can share the derivation to you.
Okay, so let me proceed with the second question from Siti Hidayah Muhammad Saleh. How you decide which solution is the first and second? Is there any possibility that the second solution is stable while the first one is not? Itu soalan yang kedua.
Okay, rather than we can also say that we cannot we can also say that the first solution, previously other research used the term upper branch solution and lower branch solution. So we can mention either it's the first or second, any of it. So there is, as far as I'm concerned, there is no previous research that conclude the second solution is stable, the first is unstable. But there are some research that may have a bit of second solution to be stable. There are also some research that found a bit of second solutions to be unstable. So you have to do the stability analysis to identify the solution, which is stable or which solution is unstable. Is it answering the question?
Yeah, insyaAllah, because the question is come from the YouTube apa channel. Right. So far that's all from the YouTube.
Okay, terima kasih Dr. Zaimah dan soalan tadi daripada saluran YouTube. Mohon para peserta lain untuk bertanya soalan ataupun penerangan lanjut, dipersilakan, kita masih ada masa lagi.
Assalamualaikum warahmatullahi wabarakatuh. Saya Nadira. Saya just nak tanya, your model just now based on Tiwari Das ke? The basic
Yes.
model. Okay, what I want to ask is, if can we apply to find the dual solution if we use the other model like a Bongiorno model, for example? Is it possible?
Yes, it is possible.
Okay, so from the figure just now tadi, dual solution means dia punya solution curve macam how do you say that, parabola kan? So the upper side is what you call the first solution or the stable one, and the lower part is the non-stable one, right?
Yes.
Is that correct?
Yes.
Okay, so just now also you mentioned for the first part, meaning this is what I understand lah. Just not make sure I understand it correctly. So the first part, you solve the usual model, which means the steady modeling. And for the second part, the unsteady one, you combine the solution for the unsteady one, is it?
Yes, the second part we consider in unsteady PDE.
And then, saya confused. Pasal bila you solve unsteady, and then from that unsteady, you can determine whether the upper and lower part is stable or unstable. How is that? Macam mana dia relate? Because it's two different model kan, satu steady, satu unsteady. But then you draw the conclusion just from the unsteady one.
Oh, kalau Dr. Nadira tengok, if we consider unsteady model, in the similarity variable for unsteady model different. Dia ada time. Tapi for this, kita consider ada tau. It's not the same as unsteady model yang sebelum ni.
So maksudnya the usual unsteady model kita consider time, but for your model kita guna tau.
Sekejap saya tunjuk.
Ya ke?
Sekejap. Okay, kalau if we consider the PDEs in unsteady, so the similarity variable here must have time t. But for the second part, we are considering it's unsteady, but the similarity variable here we doesn't have time, but we consider tau. But the tau is we have time in tau. So it's different model for the usual unsteady yang kita buat. So the different here kat sini similarity variable ni.
Okay, but the solution from for the lower branch just now is from this model, right?
Okay, to solve. Yes. Okay. Okay, to solve these equations, to solve the second part, it is depending on the first part solution. That's why we have 4 code here, code A and B, code C and D. So to run code C and D, we must have the result from code A and code B. So the solution, the numerical value is taken from code A and code B, the result from first part.
I see. Okay. All right, then it makes some sense. All right, thank you.
Okay.
Terima kasih Dr. Nadira atas soalan yang diajukan. Ada soalan lain daripada peserta? Silakan.
Daripada YouTube ada lagi.
Okay.
Ini
Mas Anuar,
daripada
mohon bantuan.
Siti Hidayah Muhammad Saleh. What is the most significant application for this area? Clearer view to and plain to those. Itu sahaja soalannya.
For the application, clearer view. So, as mentioned by Dr. Siti Kuzaima, we can see in the coolant system, the heat transfer also can cause when something hot, it can also cause the plate to be stretched or shrink. So it is one of the application that can be seen. Is it answering the questions?
Alright, insyaAllah.
Okay, terima kasih soalan. Ada lagi soalan? Dipersilakan, kita masih ada masa lagi. Peserta daripada saluran Google Meet boleh bertanya terus soalan. Saluran YouTube boleh bertanya melalui chatting. Okey, tak ada soalan Okey, kalau tak ada soalan, sebelum kita tangguhkan majlis kolokium ini, ingin saya kongsi bersama beberapa isu yang berkaitan dengan kolokium. Mulai hari ini kita jemput pensyarah cawangan. Banyak pensyarah cawangan telah saya jemput untuk menjadi peserta. Yang keduanya, pada masa akan datang, pensyarah cawangan juga akan dijemput bersama untuk membentangkan penemuan ataupun research mereka di kolokium ini. Kepada para pensyarah yang baru membentangkan kerja di SKSM 28 baru-baru ini, InsyaAllah saya akan hubungi tuan-puan agar dapat berkongsi penemuan tuan-puan di dalam kolokium ini pada masa akan datang. Seterusnya, pada 5 Oktober bulan hadapan, Jawatan Kuasa dan Latihan FSKM akan mengadakan bengkel Standard Marking Scheme and Construction of Question for Assessment. Tumpuan akan diberikan kepada pensyarah baru melibatkan cawangan-cawangan UiTM di banyak cawangan di seluruh negara. Okay, itu antara isu-isu terkini daripada Jawatan Kuasa, Kolokium dan Latihan. Jadi pada petang ini saya mengucapkan terima kasih kepada semua peserta sama ada melalui saluran Google Meet ataupun YouTube.
Doktor, ada soalan lagi daripada YouTube.
Oh, ada.
Lagi satu.
Silakan. Kita memang masih ada masa lagi. Silakan Pak.
Baru tulis di sini daripada Syuhada Ishak. How to choose the value to decide the solution for the dual solution? Is it based on the critical point value? So itu soalan yang dinyatakan.
Okay, how to choose the value? Okay, the value, you can refer to other previous research, the range of value. So from that you can identify, but basically you will know that for some parameter involved, only the shrinking case will have a dual, but some problem we will have both stretching and shrinking that have dual solution. So from my experience, I refer to other problem. So this kind of problem is almost the same. So we can see that also there exists two solution for the only shrinking case. So the value of critical you have to identify, you have to know, so that we can know that less than critical value, it is no longer can be used. We cannot use boundary layer approximation. So basically, it just refers to other paper. Either this solution, the paper involved in having a second, both stretching and shrinking, two solution for stretching and shrinking, or only for the shrinking case. So that's it. That's all.
Terima kasih kepada yang bertanya. Seterusnya, jika ada soalan, kita masih ada masa lagi. Ada soalan? Terutama calon-calon yang ingin membuat PhD, mungkin di bawah seliaan Dr. Syazana, mungkin boleh bertanya dengan lebih detail kalau berminat mungkin. Okey, jika tiada soalan, andai kata ada soalan akan dibangkitkan kemudian, boleh berhubung terus dengan Dr. Syazana untuk pencerahan selanjutnya. Jadi, kita tangguhkan dahulu kolokium kita kali ini dengan surah Al-As dan tasbih kafarah. Sekian, wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Terima kasih.
Terima kasih Dr. Agus.
Ya, sama.